Hello and welcome to Tech Talks featuring the PLC Interface Relay Series. My name is Andrew Bogaczyk, Product Marketing Manager.
And I'm Clint Hommel, Associate Product Marketing Manager.
And Clint, last time we got together, we talked about some application-specific relays. And I think you're going to explore a few more of those with us here today as we talk about some of the common problems you could see in your applications. And first and foremost, let's talk about maybe the installation or troubleshooting side of things. Do you have something to help solve some of that problem for us?
Yes, sir. And at 700 part numbers, we're not done with our tricks yet. We got lots of cool stuff to talk about. One of the first products I wanted to show you is the manual switch PLC relay. So this relay, as you mentioned, is very useful for testing and commissioning. If you remember with the relay, we have to apply a signal for the contacts to move. But sometimes it's not possible for that signal to be applied because the system's not started, or you need to simulate an output when the program is not calling for an output. So it's very simple. In that case, we're just going to use a screwdriver to be able to manually select on or off.
Well, that's very simple.
Very simple, but very, very, very useful. Otherwise, you'd have to remove some wires from the base and basically put a jumper in there to do the same thing. So screwdriver versus wiring.
Yeah.
I think this wins every time.
It's easy to use. So that's how you can manually switch a contact. But how do we know that the contact is in the correct position? There are times where we have contact welding issues out there potentially. How do we know the contact's in the right spot?
Yeah, that's actually another great point of application, a specialty application, which we would call a force-guided relay. So force-guided relay actually has, in this case, two poles in parallel. If one welds, the other relay contact will stay with it so that we don't get a false positive or false negative that this thing is switched on or off when it's not. So we use it as a feedback mechanism, often found in safety circuits, for example, to detect a malfunction of the relay.
That makes a lot of sense, is that we know, okay, we're no longer getting any signal from this. There's an issue.
Excellent.
We need to check that relay out.
Exactly.
Perfect. So that talks about, how do we see what happens when a contact welded? But as I think of contacts welding, I think of high power loads, right? So do you have anything to help us when it comes to high power loads?
Yes, we do. So high power loads are the number one enemy of a relay contact, right? They are electromechanical devices. They have a finite service life. The more the amperage, especially inductive loads, the faster that relay contact's going to wear out.
Makes sense.
So what we have here is a very special technology developed by Phoenix Contact. It's called hybrid technology. And if you recall, a solid state relay has no moving parts,
right?
But it does get a little warm. It needs more space for the same amount of current. And electromechanical, we just mentioned, they weld, they fail.
Yes.
But the real secret sauce here is hybrid tech allows us to take advantage of the best parts of both technologies.
Okay.
So we're going to use the solid state component to start and switch off the load, but we're going to bypass that with a regular mechanical relay while it's running, so it doesn't produce a lot of heat. And that gives us really 10 times the service life of a traditional relay in a comparable application. So the hybrid relays are available for AC and DC loads up to 250 volts.
Wow. So you really are talking the best of both worlds. You're integrating solid state, electromechanical to extend the service life. So again, universal relays can do the job, but maybe an application specific does it a little bit better.
Absolutely.
So we just talked about high power loads. Let's talk about some low power, the lowest of powers. What do we have? What do we have when it comes to PLC relay there?
So instead of contact welding, what we can have is contact oxidization.
Sure.
Right. So the typical relay contact material is a silver tin oxide. And if you don't have enough current in your signal, whatever you're switching, it cannot effectively burn off the oxide. And over time, that oxide builds up on the relay contact and prevents a good quality connection from occurring.
Sure.
So the simple solution is we're getting gold, baby.
Gold plated.
We're going to gold plate this relay, and just a very fine, just a few micrometers. We're not making it out of solid gold, but that gold has a very unique property in that it does not oxidize in atmosphere. So we can reliably switch a low current signal over time without any fear of that signal degrading due to contact oxidization. In fact, it's the same reason that many HDMI cables, for example, are gold plated, to ensure the integrity of that low power signal.
That's perfect. Yeah. So we're seeing it in the regular industrial world as well as the commercial world, because gold plating is important for that high quality signal and ensuring it does what it's supposed to do.
Yes.
That's awesome. So we learned more and more about some of these different relay is a part of the 700 different pieces in that portfolio. So next time we get together though, I think we're going to spin it a little bit and talk about how can we speed up the actual wiring process when it comes to a bank of relays.
I'm looking forward to that one.